Folks, Matthew Lanigan here with BayWa RE. We're just going to give people another minute or two. I see people are signing in and we'll be right back with you. Thanks. Hey folks, Matthew Lanigan here again with BayWa RE. I'm the Chief Commercial Officer here at BayWa. Really appreciate y'all taking the time out of your busy day to spend a bit of time learning about our charge controllers with Phocos. Just a couple of quick housekeeping notes before we get started. This will be recorded, so we do have a YouTube channel. It'll be shared on there later today. So if you haven't signed up, I'd like to encourage you to sign up for our YouTube channel. You can find this webinar and all our past webinars on there. It'll also be shared in our monthly newsletter. We do encourage questions, so please be sure just to type them in the bottom right corner, and we will answer them on the fly as best we can. Continuing education is very important and fundamental to BayWa internally, and we're happy to be able to share that with our customer base as well. So without further ado, I'd like to introduce Mohammed, Senior Product Manager with Phocos, and Yusuf, Sales Manager for USA and Canada. Gentlemen.
Hi, everyone. Thanks for joining us. My name is Mohammed Kari. I'm a Senior Product Manager at Phocos. A bit about me, I have a background in electrical and computer engineering. I've been at Phocos for over 7 years now. Most of that time I've spent in the R&D department working on solar charge controllers, hardware and firmware. Agenda for today. So we will briefly talk about Phocos and off-grid systems and their applications, and really focus on solar charge controllers, specifically our Eco-NT family of controllers. We'll discuss their key features, their certifications. I'll also briefly go over another industrial controller family, which is the CIS series of controllers, and we will end with a high-level description of what we call the Phocos AnyGrid ecosystem. So what is Phocos? So our mission is to enable universal, reliable energy access anywhere, anytime, and for any grid, which I'll cover later. I'm very proud to be part of an organization that wants not just access energy for all, but a high quality and reliable one. So we marked the 20-year milestone a couple years ago. So we've really we've been doing design iterations for over 2 decades, which really translates into a high quality in our product. In the last few years, we've also transitioned from being your off-grid partner to your any-grid partner, and we've expanded our product offering to really meet more energy access challenges and more user cases. So our product portfolio consists of, as of today, MPPT charge controllers. I would say these probably make about 1/4 of our solar charge controller product portfolio, the rest being PWM solar charge controllers. We also have off-grid and hybrid inverters for different markets, both for the American 120 VAC voltage and the 230 VAC model for other regions of the world. We also have refrigeration products and monitoring and communication that we've launched for many of our products, either through PC software or through a cloud portal. So off-grid systems, so solar power systems have several basic configurations. The first one is known as PV direct, which is the most basic one, where the PV panels are directly wired to the loads. Because the loads must be DC in this case and with only power during the day, this limits the use case. A good example is solar water pumping applications. Another configuration is off-grid, also known as standalone, which have more use cases as they introduce battery to store energy. Since they introduce batteries to store the energy from PV, it can be used later at night, and so that opens the use cases. Then another case is grid tie, also known as direct, and it basically consists of inverters injecting AC currents into the grid. And the last configuration is what's known as grid interactive, which is basically grid tied but introduces the backup option. They're also known as multi-mode configurations. So photovoltaic off-grid standalone systems are typically used when there is no electrical grid access or the cost for grid connection is too high. So this is the case for remote areas, power for satellites, and they can support both DC and AC loads. So some applications are pretty much anything you can think of that is not connected to the utility grid. Boats, recreational vehicles are a good example, as they now have a lot of appliances. Lighting, so solar street lights or landscape lights are also good application examples. And of course, industrial applications, whether they're oil and gas, traffic signals, telecom towers. So an off-grid power system consists of 4 main components. Battery is a critical one. It's typically the most expensive and the most likely to fail. And then there's the charge controller, which basically looks after the battery, and then the loads that the user is trying to run. The loads can be connected to the charge controller directly if they're DC or through an inverter if they're AC. Some more recent off-grid system configurations basically would combine the inverter and the charger, so either through an inverter charger or a hybrid inverter, also known as an all-in-one inverter or a multi-mode inverter. So a charge controller is basically the interface between your solar PV array and your battery bank. And it's the interface, and it also interfaces your battery bank and the loads, whether they're DC or AC. And the mission of the charge controller is really to protect and extend the battery life. So it protects it from overcharging, and it protects it from over discharging. So undercharging can cause sulfation, which is basically the formation of lead sulfate crystals on the battery plates, and this really diminishes the performance and can lead to an early battery failure. It's one of the leading causes of lead acid battery failure. Overcharging is also just as bad. It can cause corrosion and allow for excessive gassing or high temperatures causing damage. Another mission of the charge controller is to protect the sensitive DC equipment it's connected to it. And so overall, really, the charge controller maximizes the system return on investment. So it increases your system value and life, and it can provide really key information for troubleshooting or verifying your system, whether it's in terms of design and sizing it according to your loads, or even whether it's related to the installation and the wiring on the site. So charge controllers apply a multi-stage charging profile, which is a safe and effective method of charging lead acid batteries. The first three phases are bulk, absorption, and flow. Bulk is also known as boost, and it's a period of constant current and increased voltage that really provides most of the charge. Technically, in PV systems, it's not constant current, just because of changing conditions such as irradiance that affect the current. The second stage is absorption, which is also referred to as a soak or a top-in stage. And basically, current is dropped so that the voltage is held constant for a controlled period of time. So this gives the battery the opportunity to absorb the charge completely and fully. The third stage is the float stage, which is a lower voltage trickle charge that is delivered to really maintain the battery's full charge without overcharging it. This is mainly to counter the high self-discharge nature of the lead acid batteries. And the last stage is the equalization, which is necessary for flooded lead acid batteries and done after a certain number of days. And basically, its aim is to reverse the buildup of negative chemical effects, like stratification. So basically a condition where acid concentration is greater at the bottom than at the top of the battery. So some key features of solar charge controllers. So current and voltage are one. The nominal voltage of the controller. So nominal voltage is basically a sort of class or category to help match panels to batteries and loads. So a solar panel with a 12-volt nominal is used to charge a 12-volt battery, although it has, an open circuit voltage of about 22 volts and a VMP of 17 volts. So most of our charge controllers have an auto detection and a nominal voltage of 12 and 24 volts. So they can work out of the box for 12-volt systems or 24-volt systems. Current is another important specification. The industry usually refers to the charging current. So when we say a 20 amp controller, we mean a controller with 20 amp output current of charging to the battery. It's an effective convention used really because of the battery capacity is typically used in amp hours. So for example, a 20 amp controller for a 200 amp hour capacity battery means that you'll be able to charge it 10% of its capacity in 1 hour. Another convention that's specifically used for MPPTs is we add the panel voltage before we specify the charge current. And this is not the case for PWMs because PWMs, the panel voltage is usually has to match the battery voltage, but that's not the case for MPPTs. So MPPTs, the input voltage of the panel can be much higher than the output battery voltage, depending on the topology. So when we say an MPPT of 130, we mean 100 volt input voltage up to 100 volt VOC and 30 amp output current. PWM versus MPPT is another key feature to look out for. They each have their strengths and weaknesses. As I said, for PWM, you have to have a nominal matching of the input voltage and the output voltage. Typically, you don't want a VOC more than 2x the maximum battery voltage. So for a 12 volt systems, if you consider it 15 volts, then you want up to 30 VOC. MPPTs, operate the panels at the maximum power point. They are more expensive because they have higher components for their topology. They also come with some weaknesses such as power losses through the switching, either because of the higher frequency switching and also the filtering that's necessary because of that switching. PWMs can be stacked in parallel, but increasing the current also comes with having to increase the cable thicknesses. So although they are cheaper, that also has an effect on cost. So overall, really the PWM versus MPPT really depends on the system, the environmental conditions, and a trade-off analysis of the overall picture, basically. Then we have certifications. So certifications are basically a way to ensure the product is safe, functional, and compliant with some benchmark relevant standard. So it's certainly an indication of quality. IP rating is another key feature. It's basically a code that classifies the degree of protection provided by the enclosure as defined by an IEC standard. So it really defines the levels of sealing effectiveness against ingress, which is intrusion from some outside matter, such as dirt or water. Data logging. Data logging is another good feature to have. It's not uncommon to find out that you have design problems in terms of system sizing or install issues after the power switch is off suddenly. And a charge controller with an integrated historical data logger, it really allows you to prevent problems going undetected for a long period of time. So it's really a good feature against the typical faults in an off-grid system. That are generated by either excessive power usage, battery undersizing, insufficient power generation, install issues, etc. And we'll go in those deeper later. Another feature is a low voltage disconnect. So low voltage disconnect stands for, so LVD stands for low voltage disconnect, and it's a feature that disconnects load when a certain set point is reached. Low voltage disconnect types depend on what that set point is and exactly how it's reached. But yeah, generally speaking, they prevent the over discharge. So one type, they prevent the over discharge just by disconnecting the load when that set point is reached. So so the one first type is the voltage based, which basically uses the voltage set point. And for lead acid batteries, voltage and SOC are almost linear. So the state of charge of the battery is predictable from the voltage. And so voltage based is basically as soon as the voltage is reached, the loads are disconnected. And of course, there is some time and delay there to prevent reaction based on quick transients. Another type is adding to that voltage-based algorithm also a current relationship. And this is really to counter the effect of when voltage is dropping because the discharge current increased suddenly because of the connection of a new load. Then we have the user interface, which is basically, either the controller having an LCD or some LEDs, some indicators of its state of operation. or allowing the user to change settings on the fly and customize the controller operation to the user's specific needs. Another feature is reliability. So this is really important for any kind of system, but it's critical for off-grid because of the nature of the sites being remote, and a failure really means a failure really increases the cost of the maintenance and the cost of the downtime of the system. So things to look out for here are really the warranty of the product and the product lifetime. I have seen manufacturers provide MTBFs, which are mean time between failures, but it's important to know that those are, MTBFs don't really have to do with life expectancy of the product. So the lifetime is basically the period of the time between starting to use the product and the beginning of the wear out phase. And the wear out phase is the point when the number of units failing really starts climbing steeply. So although MTBFs and the lifetime both lead to observed failures, they're different. MTBFs, in theory, really estimates the failure rate for every year of operation. So it's a statistical approximation of how long a number of units should operate before a failure can be expected. So it doesn't really represent how long the unit will last. And also MTBFs only apply during the useful life of the product, where the failure rate is kind of constant. So with some random failures, and so not when the wear out phase actually starts. So it's important to keep that in mind. Some features I don't mention here. One is the efficiency of the product, of the charge controller. So that can be both in tracking efficiency for MPPTs, for example. So the ability to really track the maximum power point and operate it there. And also the conversion efficiency. So the ratio of power in versus power out, and how much power is basically lost through the conversion mechanism. Another one is G rating, and basically it's operating the device at less than the rated maximal capacity to either protect it or increase its lifespan. I've seen many products on the market, for example, where they rate the product as a 30 amp or a 40 amp MPPT, but it really can only operate at that current at an ambient temperature of 25 C. As soon as the temperature increases to 35 C, it is not anymore a 30 amp or a 40 amp MPPT as rated on its data sheet. And so looking for G rating and G rating curves versus temperature, power G rating curves versus temperature is something to keep an eye for. And there are many other secondary things to keep in mind that are harder to see in a data sheet or in a user manual. Certainly the controller's algorithm is one of them. So the way, for example, it sweeps the PV panel curve to find the maximum power point, especially in shading conditions where you could have multiple ones. But also the response to certain transients, whether it's loads being connected or loads being disconnected. So that's something that you can really find. That's it is a good feature when they work really well as they're supposed to, and it's easier to see it in a system that's tested and data logged versus a data sheet. So our charge controller portfolio as of today really consists of residential controllers and industrial controllers. Today we'll really focus on the industrial ones. The residential ones have lower IP rating and are basically more basic. So going from left to right, we have our CM series, which doesn't have actually a low voltage disconnect. So there are no load terminals. So it's really protecting against the charging but not the discharging of the battery. The CML USB adds that load voltage disconnect capability we talked about, and some other features such as more LEDs for indication, for state indicators, and a USB charger. The CXN up adds on top of that a data logger, a display that really, with navigation keys, allows you to see many parameters and also adjust and change settings. It also comes with lighting control for applying specific timing profiles to your load. And then the industrial series, we have our Echo, which we'll talk about today in details. And so those have a low voltage disconnect, LEDs for indicating charging and SOC states, and different certifications. The CIS series is very similar in many ways, with an IP68 ingress protection code. They are more tailored for streetlight applications because of the lighting programs that can be applied to them, the integration of LED drivers, etc. So the Echo NT is really ideal for industrial systems, harsh environments, because the PCBA is fully encapsulated, except for the terminals, but everything else is potted. It has an intuitive LED interface that really allows simple troubleshooting. So the green LED indicates the charge state, so whether the panel is detected and used to charge the battery or whether it's at night. The yellow LED indicates your state of charge, and the red LED shows any system or errors or faults. The low voltage, so we talked about a little bit earlier, it prevents the batteries from over discharge and prevents the battery sulfation process, which affects the lifetime of the battery. It protects the battery from overcharging and the load from over voltage. There's a temperature compensation that's limited to 15 volts. The high voltage disconnect not only disables charging, but also disconnects the loads to protect them. And it has a feature of a reduced absorption time that's really dynamic and depends on the battery state. So if the battery usage is very heavy, then it uses a longer absorption charge, and if it's very light, then it uses a smaller absorption charge. The Echo NT comes with protection against user connection errors, such as reverse polarity on the battery side or PV side, and short circuits. And I'll mention here that this is a really full protection. You know, in the word protection in the industry is, you know, sometimes refers to many things. Sometimes it's protected in the sense that the unit will fail but will not explode or go in flames. So here at Phocos, and in this case, we really mean a full protection, as in you can connect the unit with reverse polarity for a long time and it won't fail in any way. The Echo NT series also comes with a compact design, so very small footprint, which really allows an easy installation and allows it to fit in, you know, many system enclosures, small or large. It's one of the most compact charge controllers for a similar amperage, and they come both in 10 amp and 20 amp SKUs. It comes with an anodized aluminum enclosure, and the screw terminals allow for a wire convenience and make the install more flexible. As I said, the PCBA is fully potted except for the terminals. So except for the terminals, it's essentially an IP68 product. The IP68 code that I mentioned earlier, the first digit indicates the level of protection from solid objects or dust, the scale being from 0 to 6. So this has the highest scale. And the second digit indicates the protection level from liquids. And the scale is 0 to 9, and in this case, it's rated at 8. one feature that we do for our charge controllers is really the OEM customization. So we have powerful existing partnerships, one of them being with BayWa. And so we're always willing to customize and optimize firmware, hardware, or the mechanical to really meet some specific applications needs. So in terms of the EcoNT and our partnership with BayWa, we've customized the settings. The emergency high voltage disconnect set point, for example, is 15 volts and 30 instead of our default 15.5 and 31.0. The first one for 12 volt systems and the second one for 24 volt systems. And this is really a requirement to protect against sensitive equipment, and is really based on the extensive experience BayWa has specifically in the oil and gas industry. So some certifications. It's important to mention all of our Phocos products are CE compliant. So CE is basically a regulatory standard that verifies products are safe for sale. It's a self-declaration of conformity and not granted by a particular body. The manufacturers are really responsible for the proper use of the CE marking. And this makes it tricky because what really this means is that anybody that a CE mark on a product may not mean the same thing, even if it's the same category of product, because it's really up to the manufacturer to do its due diligence and test its product according to all the CE standards that are applicable to that product. So it's not a standard such as UL that you can go to a third party official lab that will give you a certification for it, and that it's one specific standard, and it's the test and what is applicable to the product is really clear. At Phocos, we ensure that all of our products are compliant with all the applicable European regulations, and we have proper documentation for this using third-party lab, and we issue a declaration of conformity for every product on our website. So some of the CE tests that we specifically test and comply with. So one is the low voltage directive, which is basically a standard for electrical safety. It's not a specific standard, but it relies on many IEC technical standards to really comply for producing safe products. Then we have electromagnetic compatibility standards, so specifically EN 6730, EN 55014, and 55022, which are basically for emission of radio frequency disturbances in certain frequency ranges, either through the wires, so specifically conducted through the wires, or radiated in air because of the wires or the product. This also includes the restriction of the use of certain hazardous substances. And we have many EN 61000 standards, which are really about the immunity of the product to certain industrial and residential levels of conducted disturbances. And this one is really an indication of quality and of how rigid the product is, because it shows that it's immune to many kind of disturbances, whether they're surges, whether they're electrostatic discharges, etc. EcoNT, other certifications other than the CE ones we just talked about. The product is UL listed to UL 1741 and CSA C22.2. So this standard really applies to inverters, power converters, controllers, and any interconnection system equipment that is used with distributed energy resources. So it's a really rigorous testing and review of performance, quality, and safety process. So they look at a design review on the schematic level and on the layout or the printed circuit board assembly level. They do a lot of charge testing on the system battery voltage that you're rated to. And more importantly, they really look at many kind of different responses. So that includes responses to connection errors from the installer, from users. That includes response to broken components. So a good example of that is, if a temperature sensor component on the printed circuit board is broken, which they break intentionally or remove, then they want to see that the response of the product is safe to that, so that the product, for example, stops charging and protects the installation and itself. And they also look at response of the response of the controller to intentional heat application. Another standard is UL 121201. So basically, the EcoNT is Class 1 GIF2 certified. So this means that it's been designed and certified to safely operate in environments where flammable gases or vapors exist and have potential to rise to ignitable concentrations. And so this is another rigorous testing and review of safety specific to hazardous locations. And they also look at the schematic and a review of the design and do an assessment of the explosion risk. So when this is coupled with UL 1741, it really means that this controller meets very strict environmental and thermal requirements. All of our controllers are manufactured in an ISO 91000 certified facility. So this is really a standard for quality in the manufacturing industry. And so at Phocos, we really, we consider safety, reliability, and performance really as a standard for us and as a differentiator in the competition. So what that means is that we don't compromise for cost efficiency on the components. So relating that to what I said earlier, we definitely ensure that wear out phase of the components is well beyond our warranty, and we only use proven and high quality components, and that's from tier 1 manufacturers and suppliers, and we've been using those for 20 years now, for 2 decades. We do thermal and vibration testing on all of our controllers at the manufacturing facility, and we have an extremely low return rate. In the case of EcoNT, it's been on the market since 2015, and our failure rate is below 0.1%, and that's really because part of that is obviously the experience and the iterations we've done over 20 years from feedback from the field, etc. But it's also from really pushing our design random failure due to the components well beyond the warranty. So and we do provide a 5-year warranty on all of our solar charge controllers. Okay, the next is the CIS family. So the CIS family has many similar features to the EcoNT, comes in both PWM and MPPT SKUs. The enclosure is basically an aluminum extrusion where the PCBA is fully potted, so it's an IP68 product. A key difference with the EcoNT is that it comes with wires, and that really allows the users to use their favorite connectors that are weatherproof. It brings more features than the EcoNT in terms of its programmability, so you can apply really specific charge profiles to it via our PC software. So you can really customize every aspect of the charge profile, whether it's the duration of one of the stages we talked about earlier, whether it's the set point of those stages, and also the discharge level, so the low voltage disconnect method. Earlier we talked about different types, whether it was a voltage set point or a voltage plus current, and so this really gives you the ability to really choose and customize all of these for your specific application requirements and user needs. The load control comes with a light timer and a programmable dimming, and some of these SKUs in the CIS family actually integrate an LED driver. So LEDs are basically current-driven devices, and their brightness is proportional to their forward current. And that forward current can be controlled in many ways, but we use the constant current source method for regulating that LED current. And this this eliminates changes in the current due to variations of the forward voltage. And so basically it ensures a constant LED brightness. And many LED applications require dimming, which basically adjusts that brightness. And for the CIS family, we use PWM dimming. So analog dimming is basically you provide 50% dimming is achieved by providing 50% of the current. The PWM dimming is achieved with a full current applied at a reduced duty cycle. Of course, the frequency of that duty cycle is high enough so that the pulsing is not visible to the human eye. But so some of these MPPTs and PWM controllers within the CIS family come in with this integrated LED driver. A great feature of some of them too is that this LED driver is programmable. The current of the LED driver is programmable. And really what that means is that you can really customize your product. You can really nail down the consumption of your load, in this case the LED, from the battery. Because by having the ability to change the fixed current from, let's say 600 milliamps to 800 milliamps or to 1400 milliamps, that really gives you the ability to set the depth of discharge of your battery, which is a big feature in sizing your system, right? Is how much do you want to take out of the battery, and the ability to know exactly that allows you to count for autonomy days, etc. And so this really brings a lot of features for the lighting industry. The CIS family, because of its programming capability, is compatible with lithium batteries, so you can you can change you can disable the temperature compensation of the voltage set points, etc. And that compatibility comes with Syscom, as I said, which is a PC software that allows to change those settings. The PWM controllers within the CIS family are also UL 1741 and Class 1 DIV2 certified, just like the EcoMT, in addition to all the CE standards I mentioned earlier. The MPPT SKU of the CIS family comes with a data logger for troubleshooting. So data loggers are important because, as I mentioned earlier, they really allow you to troubleshoot your off-grid system using using all of the charge controller's data. So as I said, it's not uncommon to find out you have design issues because you didn't account for certain characteristics of the system, whether it's temperature or whether it's loads changing or addition of loads or anything like that. So faults in an off-grid system are typically generated by excessive power usage, so using more loads, more load power than you predicted. Maybe battery undersizing, so the capacity is not big enough to run the loads. Potentially some insufficient power generation, so you're not generating as much power as you anticipated for some reasons affecting the panels. And some fault can be because the batteries became weak, or because shading is happening on the panels, or because of some kind of faulty condition. So whether it's faulty wiring or faulty grounding. And the data logger that we've integrated really helps you identify not just which of these conditions is happening, but why is it happening, right? So, in the case of excessive power usage, where more load power are used than anticipated, the data logger gives you the ability to see all of your low voltage disconnects. So you'll be able to see that yesterday one low voltage disconnect happened, or the day before that it also happened. And so, that occurrence tells you something about the power usage versus your system sizing. There are many other parameters that you can also see. So you can look at the SOC, the maximum state of charge. So the data logger includes a lot of statistics, and looking at your maximum SOC during that day or your minimum one can tell you a lot of information. So if your maximum SOC was low, that is an indication of too much load power being used, and so your battery didn't get the chance to go to 100% SOC, for example. Or it could also tell you that your battery is too small for your loads. Another good example is, so the data logger gives you the amp hours into the battery and out of the battery, which are basically aggregated and saved into the controller. And so if you have insufficient power generation, so basically less PV power being supplied than what you expected or what you calculated, then you'll see that your amp hour into the battery was very low. And so, excuse me, that indicates the issue in this case. Beyond typical sizing issues, as I said, you can also see if your battery is very weak. So if you identify a difference between your minimum battery voltage and your maximum battery voltage, while at the same time there wasn't many change of amp hours, that indicates a weak battery state in that case. Same thing for installation issues, whether it's a poor connection of wiring or whether it's a damaged wire. So being able to see your voltage, current, temperature changes and values at a certain time really allows you to troubleshoot those conditions. And last but not least, I just wanted to cover briefly our AnyGrid system. So AnyGrid is basically a very flexible ecosystem with three major components. One is our energy storage solution, which we launched this year. The second one is the AnyGrid inverter itself, which is a hybrid inverter charger. And the third one is the AnyBridge, which is basically an internet energy gateway that communicates with the system, gets all the data bidirectionally, and then sends that information to our cloud portal, remote monitoring platform, which is accessible via cloud.phocos.com. And so really the value of the system is that it provides a seamless integration between power conversion and energy storage, while at the same time optimizing the use of many available energy resources, whether it's the grid, whether it's the PV panel generation. So the hybrid inverter integrates an MPPT solar charge controller, an 80 amp MPPT, and an AC also battery charger. And the ability to really mix all those energy resources and prioritize one versus the other really adds and enables that flexibility and optimization of the system. A good feature of it is also its scalability. So both the AnyCell energy storage solution and the AnyGrid can be scalable and paralleled in terms of either capacity. So we have several SKUs that come in different power ratings. So for example, 5 kilowatts or 6 or 3 kilowatts or 8 kilowatts, depending on the model. And you can stack those either to achieve certain topologies, such as 3-phase versus single phase or split phase. But you can also obviously stack them for capacity, so that instead of 1 unit with 5 kilowatts, you could have 3 units with 15 kilowatts, up to 9 units in parallel. And the AnyCell is an energy storage solution, as I said, that we introduced this year. It comes with a lithium iron phosphate chemistry, which has a safety and lifetime advantage over NMC, lithium, nickel, manganese, cobalt. It's indeed much less flammable, and it has a much higher temperature to reach a thermal runaway. So safety really, as well as the lifetime advantage in terms of cycles, is really the reason we went with the chemistry. It comes with a 10-year warranty, and it really is compliant with all the relevant international safety standards, as far as energy storage solutions are concerned. It has a high charge and discharge rate, so you can discharge it up to 1C, so you can get 100 amps out of it, which is also another advantage of lithium iron phosphate batteries, specifically compared to lead acid batteries. And so the ability to really use all that depth of discharge, all the way down to 10% or 0%, and we warranty the 6,000 cycles at an 80% depth of discharge. And also what that means is that our warranty is not just, it's not that after 6,000 cycles, the battery is failing. It's that it's a warranty against an 80% capacity of the battery after 6,000 cycles. So after 6,000 cycles, you're still left out with 80% of the capacity of the battery. And finally, I mentioned earlier Phocos Link Cloud and the AnyBridge Internet Gateway being a component of our AnyGrid system. This is something that we're focusing on and continuously updating and upgrading. The AnyBridge comes with an automatic over-the-air update, so it updates itself to be compatible with the releases that we constantly do on the front end side of the cloud. And so this online web portal Phocos product basically enables managing and controlling the Phocos product. In this case, it's already compatible with the AnyGrid, PSWH and PSWB, and we're adding compatibility for the AnyCell energy storage solution. So it allows you to log in from any device that has an internet browser, and allows you it enables you to have a remote control and management of the system from anywhere in the world. And that said, I'll open the floor for any questions.
Hi, folks. Any questions out there? It's a great opportunity while we have the folks from Phocos with us here today.
And our tech support is also can be reached at any time, either by calling us, and that gives you the opportunity to speak directly to our engineers, or emailing us at tech.na@phocos.com. And we typically answer within 24 hours. So any questions are always welcome on our support email as well.
Great. Well, I don't see anything, Mohammed, but thank you very much. Really appreciate you taking some time to educate us here. If anybody does have any questions, please reach out to your reps. One thing is they do have fantastic tech support. It's not needed very often, but anytime we've had to use it, we often get somebody in real time. Once again, I'd just like to thank everybody for spending the time here with us. If you haven't signed up for our web shop yet, I would encourage you to do so. It's a fantastic resource. You can find spec sheets, the pricing, inventory levels, install manuals. You can place orders, pay your invoices all in one spot now. So it's a really fantastic option for folks, and all the Phocos product is on there. This once again was recorded. We'll put this up on our YouTube channel. It'll also come out on our newsletter as well. So once again, thank you, Phocos. Really fantastic product, great partner. We've been dealing together for several years now, and product has been very bulletproof for us, and very happy with it. So thank you, everybody, and have a great day.
Thank you, guys.
Thanks.